Hi class, this is course 3, lesson 65, applications using similar triangles. Okay, so remember that similar triangles will have the same shape, but not necessarily the same size. Corresponding side lengths are proportional, and corresponding angles are congruent. And one of the ways that we know we have similar triangles is if we have all three angles are the same. Angle, angle, angle similarity, then we know we have similar triangles. Okay, so if all three angles are congruent, we know we have similar triangles, and we're going to need to remember that to do the first part to determine if we have similar triangles, and then remember that corresponding side lengths are proportional, so we write a proportion. Okay, so we are going to use similar triangles to find lengths of objects. What we're going to do is indirect measure. We are not going to actually measure. We're not going to take a tape measure or ruler out and measure an object. We're going to use similar triangles and proportionality to determine what those lengths are without actually measuring. So let me give you an example of how this works. Okay, one thing we could do would be like to try to determine the height of a tree. Okay, we want to know how tall this tree is, but it's really difficult to go out there and measure to the top of a tree. Okay, but let's say you know how tall you are. Okay, what we can do is utilize the fact that the sun might be shining over here. Okay, we have the sun over here, and its rays are going to make some triangles. Okay, what's going to happen is we're going to get some shadows on the ground. So let's say the tree's shadow goes out to here. Okay, that's the length of the shadow, and your shadow is this long. Well, then what we can do is take the tree, or the angle of the sun from the tree, and this is poorly drawn because you'd need to go at a sharper angle, but we'll do this anyway. Okay, we'll fix these. We'll extend our shadows a little longer. Okay, what happens when you're outside then is that the angle down here is going to be congruent to this angle. That's the angle that the sun is at the moment. Also, in your triangle, let me draw the other piece of the triangle in here. Okay, you have a right angle in this corner, and so then you automatically know that this angle is congruent to this angle, because if two of the angles are congruent, the third one has to be congruent as well. So you have similar triangles. So indirectly, by using shadows of objects that you know the actual height of, you can make a proportion. And so that's what we're going to do today. We're going to make some similar triangles. One way is with shadows of objects, and another way is by actually knowing lengths. And we will get to that in just a minute. So this is kind of what we're going to do today. So here's an example. Mara Cruz wants to know the height of a flagpole. Okay, she stands a meter stick in a vertical position and finds that the length of its shadow is 120 centimeters. At the same time, the shadow of the flagpole is 30 meters long. How tall is the flagpole? Okay, now, what I like to do in this situation is to draw a picture. Okay, so I have a flagpole, and I have a meter stick. Okay, the length of a shadow on the meters, let's see, the length, the vertical position, and finds that the length of its shadow is 120 centimeters. And then I label that. I also know the shadow of the flagpole is 30 meters long. Now, these do not have to agree in units. However, the units that you use in each of the triangles has to match. So in this example here, I know that this is a meter stick. So I'm not going to write down 1 meter. Okay, 1 meter has to equal how many centimeters? Because these units have to agree. Well, it's 100 centimeters in a meter. Now, where's the rest of my triangle? It's right here and right here. I know that this is a right angle. I know that this angle will match with this angle. They're congruent because they're where the angle that the sun hits the ground, and then this angle at the top has to be congruent with the other angle, because 2 angles in a triangle are known, the third will be equal. So now I have a proportion, and what you can do is write a ratio box. If that helps you, you don't need to, but it's one way to organize your information. And then you can put the height, there's a T there, and the shadow. So in your smaller object, that'd be the meter stick scenario, the height is 100 centimeters, and your shadow is 120 centimeters. Now, this could also say what they were, like meter stick, and this could be flagpole. It doesn't matter. Or option 1, option 2, just so that you make sure to put the items where they belong. So 30 meters was the shadow of the flagpole, so that goes here. And we want to find the actual height. That's your variable. Now you have a proportion to solve. And you can do cross products. You could say, okay, what would I multiply or divide by? I will do cross products just to make sure that we have some exposure to that. So 100 times 30 equals 3,000. And then we will divide that by 120. Let's see, 240, 006, let's see, 5, 0, carry the 1, 6. Okay, so we're good there. So it's 25, and make sure you label it. This should be meters. So the actual height of your flagpole is 25 meters tall. Okay, now don't write all this. This is just for explanation of what's going on down here. You'll want to copy the diagram and then these questions or the information given. But here's what would happen. So Josh is standing facing the pond, and that's this blue odd shape here. And from his viewpoint, he could see 2 points on opposite sides of the pond. So he can see point 1 here and point 2 here. And he wants to know the distance between them, but he doesn't have a way to measure the distance directly. So he's remembering what he learned in math class, and he can indirectly measure the distance. So he marks his position here with a large stone, and he walks 10 yards towards P1. And drove a stake into the ground. He tied a string around the bottom of the stake, okay, and stretched it out in a line parallel to the line from P1 to P2. Okay, so he makes this right here. He makes that parallel to this. Okay. All right, and then okay, so he marks this parallel so that he gets that other end of the triangle that will be similar. And then he returns to his starting position, walking in a straight line towards P2. Okay, so he's making these similar triangles. So what we can do is split them apart. So hopefully you see two triangles. You see a large triangle with Josh, point 2 and point 1. And you see a smaller triangle with Josh and his second stake and his first stake. Notice that it has these two angles as being congruent. Well, he said that he walked parallel to this line, and so those would be corresponding angles. So these would in fact be parallel lines, so they're corresponding angles, which then this angle where Josh is, that's shared in both triangles, so that's congruent, which means that P2 and 2 have to be congruent as well, so we have similar triangles. So label what you know. Josh 2.1 is 45 yards. Stake 1 to stake 2 is 8 yards, so that would be here. And so what is the distance from point 1 to point 2? So we need our x here. Now, we're missing some information, right? We need to have 4 pieces of information. One of those would be the variable in order to solve our equation or our proportion. But here's the missing piece. He walked 10 yards towards point 1 and put his first stake down. So this would be 10. So you can make your ratio table again. And what you can do here is, well, or you can do this. You can say, well, what is the scale factor, right? Because that are similar triangles. What's the scale factor from the smaller to the larger? Well, to multiply 10 by a number to get 45 would be 4.5. So you can also identify scale factor. So from small to large would be 4.5. And so I can multiply my side length of 8 times 4.5 and get my length of, let's see, I have to write it like this to multiply, 40, 32, 36 decimal. So it'd be 36 yards. Now is it exactly? No. It's a rough estimate, but it should be close. So the distance across the pond is approximately 36 yards. Okay, so I gave you a couple different ways that you can solve indirect measure problems. One by using scale factor and another by using a ratio table and a proportion. Okay, that's what we're doing when we're talking about applications using similar triangles and indirect measure. I'm sure you'll have some questions, so make sure that you ask them in class. Okay, I'll see you then.